So the AI gold rush has everyone focused on the wrong thing. While companies dump billions into bigger language models, the real battle is happening behind the scenes in databases and data infrastructure. Here's the kicker. OpenAI, Google, Meta, they aren't actually competing on who can build the smartest AI. They're fighting over who can access, organize, and retrieve information the fastest. So there's an interesting secret here. The most AI breakthroughs in the last 2 years weren't actually algorithms. They were new data sets. So why is every tech company obsessing over model parameters when real winners are building vector databases? This is why the entire AI race has been about the wrong metrics from day one. So let's dive into some of this today, and I'm going to explain a lot of this for you. Welcome to Startup Hack. I'm Spencer, and here at Startup Hack, we train software developers and build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years in software development, I've mastered transforming tech teams and products. So the AI industry has been selling you a story about model intelligence, but the real revolution is happening in data retrieval systems. So I've watched a lot of different AI implementations fail or succeed in my consulting work, and I've noticed a pattern. The companies winning aren't the ones with the fanciest or the biggest models. They're the one with the best data pipelines. So let's jump in and talk a little bit today about RAG, just in case a lot of you guys may not know necessarily what RAG is. This was what really saw the explosion of AI, right? Every impressive AI demo that we've seen lately uses RAG, which stands for Retrieval Augmented Generation. And they use this to pull information from external databases before generating a response. So companies market their proprietary AI, but it's usually just ChatGPT connected to their company's database through a vector search. Now, the magic isn't the language model. It's how quickly and accurately the system can find relevant information. So let's kind of break this down here for you. So essentially, you take a document or some type of data store. So let's kind of take an example of a book, right? You take this book and you break it into chunks, which then uses an embedding model to then store it in embeddings, right? These are vector rows, right? Rows of vector mappings, and these are then stored into a database. Now, one of the big advances we've seen is PostgreSQL has actually done a really good job at becoming really efficient at these data stores. So this is great that in a lot of our projects, we're actually able to store regular data and some of these vector data together. Now, what happens then is when a user makes a query, let's say they want to ask a question about something that would have only been relevant to one chapter of that book, it actually does a semantic search and then pulls from this vector database. That way, the context that's given to the actual LLM is only the portion of the vector or the only portion of the context that it really needs. So we don't need to feed the whole book to the LLM. We really only need to feed the relevant chapters. This actually lowers the amount of context you're having to feed into the context window, and then the LLM can make a more intelligent decision based onto the response. Now, the problem with this is that as we get larger and larger and larger data sets, and this is one of the things that OpenAI 4.0 has started to really struggle with some of its hallucinations, because they've tried to be everything to everybody, this is where we start to see the breakdown of this model, right? And so this is the reason why we see that when you ask an AI system about your company's policies, it's not thinking, it's just rapidly searching through an embedded document vectors to find the most relevant text chunks. So if you want to build a killer AI product today, it's less about prompt engineering and more about context engineering, getting the right information into the model at the right time. Now, looking through the last major milestones of AI, it really was about unlocking access to new type of data sets, not inventing smarter algorithms. So there's a lot of different data sources that have come back through the last few years where we've seen this start to open. The latest reasoning model from OpenAI's own worked by accessing verifier data, essentially databases of correct mathematical and logical reasoning. So what they're doing is they're actually feeding it these databases that have been pre-designed of mathematical and logical reasoning. Now, in one of my latest videos, I made a video about how an old Atari beat out OpenAI's models in a chess game. This is because it can't be fed every single possible logical move in math. There's literally too large of a data set to even be able to break for this, right? And so they couldn't possibly give it every single one of these. And so that's why it seems so dumb, whereas the Atari was actually just built with straight logic. But OpenAI's model wasn't built for logic reasoning for plain for playing chess. Now, there are some very high-end systems out there that are and have learned Go, have learned chess, have learned a lot of things because they were actually taught the logical reasoning. See, in OpenAI's case, they were just trying to use some of this embedded content and then try to feed it this to try to feed different strategies, which it then would usually kind of take and hallucinate and make up different moves. So that's just one example, right? So the hottest skills in AI right now isn't crafting perfect prompts. It's designing systems that dynamically provide the right context to language models. So context engineering means building infrastructures to gather calendar data, email history, document libraries, and tool access before the AI even generates a response. So this is where we see that this is starting to move over time, right? Is we're seeing more and more things moving towards these systems rather than seeing trying to get the data instead of trying to do this, right? So context engineering means building the infrastructure to gather this. A cheap demo AI just takes your question and sends it to ChatGPT. But the other problem to this is also really expensive because then you're relying on the LLM to do all the heavy lifting. So there was a lot of engineers. There's an engineer from Shopify who nailed it. And he said, context engineering is providing all the context for the task to be plausibly solvable by the LLM. Now, most AI agents failures aren't model failures. They're actually context failures where the system didn't have access to the right information. So this is why these vector databases are really kind of the new cloud infrastructure, right? Everybody's in a race to try to get these as fast as they can. And this is the reason why we see companies like Snowflake, talking about a $250 million acquisition of crunchy data, right? We're talking about a lot of different systems. We're seeing Postgres start to work on vector data stores, right? These are why these are important things. Now, there's a new skill in AI, and it's not programming the model. It's actually the context engineering, right? Vector databases store information as mathematical embeddings that capture semantic meaning, not just keyword matches. So companies are spending more on vector database infrastructure than on model training because that's where the competitive advantages lie. Now, you want to get into a combination of both. You want to actually be training your own model and then storing it into these vector databases. So modern AI applications are really just fancy interfaces on top of vector search engines that can understand the meanings behind these user queries. Now, if your company has systems that aren't connected, make sure you reach out to us because here at Startup Hack, our specialty is connecting systems to help your company work to maximum efficiency. Check out startuphack.com/Spencer. We can help you out. Now, companies that succeed with AI aren't the ones with the latest models. They're the ones with clean, accessible, well-organized data pipelines. This is part of the reason we've also seen models and AI struggle on mobile devices, right? Because even if you get really good models to fit onto a mobile, it's not going to have access to that unlimited amount of data, at least not quickly, right? In the cloud, these large models like GPT-3 and 4 from OpenAI can have access to these really extensive vector databases that it can then search against semantically, right? So the boring stuff like ETL pipelines, data cleaning, embedding generation, and index optimization, this all determines more about the AI success than actually which model you're going to use. So while everyone's obsessing over which model parameter, the real winners are building data infrastructures that can scale and adapt quickly. So I've learned that data architecture isn't always trumps algorithm sophistication in most systems, right? Companies building sustainable AI advantages are investing 80% of their budgets into machine learning and data infrastructure and 20% into model access. Now, the most valuable AI companies aren't those with general intelligence. There's those with exclusive access to specialized, high-quality data sets. So medical AI companies win by having access to proprietary clinical data sets, not by having better models than everybody else. Financial AI succeeds through real-time market data feeds and transaction history that competitors can't access. Legal AI tools dominate specific practice areas because they've curated comprehensive case law databases with perfect metadata. So this is where you see the defensibility coming from data networks and not from just bigger models. So that's where context window becomes really important, right? Because the more context you can hand to the model, the better decisions it's going to be able to make. So if you can front load the amount of context that you're needing for your model with good relevant data and with a good semantic search, not just a keyword search, but actually good semantic search, that's where you're really seeing the power of these AI models get stronger. So I predict that the next AI breakthrough is really going to come from databases that can seamlessly handle text, images, audio, and video embeddings together. Now, YouTube represents the largest untapped training data set on the planet, and there's 500 hours uploaded every minute with rich multimodal information. But what they're having a hard time with is they're having a hard time taking that information and hobbling it together to be effective data for the training models. And this is why I think Google will eventually really emerge as one of the strongest players. Because with their history of search, with their history of marketing, with their history on YouTube, with all of this, I think we're going to see a huge, vast system of potential for being able to read and use this data accurately, right? Now, whoever figures out multimodal semantic search first is going to have some huge advantages and have the same advantage that Google had when they cracked the web search. Now, static training datasets are becoming less valuable than real-time data retrieval systems that can access current information. The companies winning in AI are those that can update their knowledge base continuously without retraining the entire model. RAG architecture allows AI systems to stay current with information that changes daily. This is when we saw GPT really emerge, is when they figured out RAG, right? RAG is that big breakthrough that really allowed ChatGPT to move forward and give one of the first big commercialized steps toward a RAG system. Now, this is part of how we're seeing the bubble burst, right? You guys have heard me talk about the bubble burst before. The bubble burst is that we're starting to see companies niche down, right? We're seeing specific use cases where you're seeing data that's being used for a specific use case as it continues to drive in. So let's jump over here really quick to one of these articles, because there was a big announcement from Microsoft yesterday. And so Microsoft says its new AI system diagnosed patients 4 times more accurately than human doctors. The tech giant poached several top Google researchers to help build a powerful AI tool that can diagnose patients and potentially cut through healthcare costs. Now, as we dig into this here, you're going to see that even though it's an experimental tool, right, what you're going to actually see is that they're coming through. Let's get to where it's talking about here. Built a system called Diagnostic that queries several leading AI models. So not only is it using multiple models, but it also then has a huge database of systems, right? So it's talking about all this. Microsoft said it has commercialized the technology yet, because I'm sure I'm wondering how much of, if they haven't commercialized the technology yet, is because you can see this same executive spoke on condition anonymity, because I'm wondering if how much of this data they actually obtained legally. And they know that there's going to be some huge privacy concerns if they go out and commercialize this. But he's saying, what you'll see over the next couple of years is us doing more and more providing the systems in the real world. The reason for that is because they probably are using this on data that they don't even want to release that they have. And their ability to release this safely with allowing even a huge swath of doctors to be able to get to it probably means it's probably pretty easy to hack and divulge a whole bunch of patient information. So here we go. Project Growing List, research showing that how AI can diagnose disease, both published papers, right? And showing large language model can accurately diagnose. Now, again, I guarantee behind this, you're going to find that and maybe it was in a different article I was reading, because it talked about the underlying data, right? Where was it here? So, it must have been in a different article, but this is an article that was talking about this. And so again, how they're doing this is because they've obviously curated a huge amount of data to get through some diagnosing information and then make it usable to the LLMs. Then they're also running it through multiple LLMs, doing different levels of checks. So the quality of your vector database, your vector embedding, determines whether your AI can find relevant information or return complete garbage, right? And most companies are using generic embedding from OpenAI or Google, but the winners are training custom embedding. So why is Claude Code so good? It's because they have been trained on some of the best sources of code, right? They're very specific to that. They've embedded it onto code so that when you go look for things, their semantic search is finding code that's very relevant to exactly what you're working on. So the artist is choosing the right embedding models, chunk size, and indexing strategy for your specific use case and your data characteristics. Let's kind of go back to our model here, right? So there's a lot of strategy that goes into knowing how to break up your chunks, how to do your embeddings, which embedding model to use, right? And then how to store that data so that you can quickly retrieve it. And then also how powerful your semantic search is, right? So much where everybody's focused on the LLM itself, so much of that data is actually in this portion of the loop that you have to figure out first, because LLMs have a limited set of memory, right? We remember Karpathy talking about this encyclopedic knowledge, right? So this is that encyclopedic knowledge while still being able to be stupid, right? We talked about this fragmented, I forgot what it was called, from Satya Nadella, or from Google CEO, where we talked about this fragmented knowledge where it actually sometimes gets this information, where he called it brilliantly stupid, right? Because its ability to do these semantic searches against these huge data stores is really powerful, and yet the LLM can still hallucinate on the results, right? And so it may get this, but it may interpret that data wrong, right? And that's where this is getting, where we see this really coming down to. And it's the reason why we see so much work going into the semantic search, into the embedding, and into your chunk size, as well as your embedding model. A lot of this is actually coming up with how powerful your AI is, right? So think of embedding as the translator between the human process and the translator between the human concepts and machine understanding. A bad translator will ruin everything downstream. Now, the most effective AI systems combine traditional keyword search with vector similarity search to get the best of both worlds. Pure vector search will miss exact matches in specific terms, while pure keyword search can't understand conceptual similarity. So advanced search engines like Vertex AI use hybrid approaches with re-ranking algorithms to score and prioritize results. The companies building the best AI products have sophisticated query processing that transforms and optimizes searches before hitting the database. So semantic search needs keyword backup for edge cases, and keyword search needs semantic understanding for context. So the magic happens in the fusion layer, where different search strategies get combined and weighted based on quality characteristics. So while everyone's focused on model capabilities, the real advantage is in building AI systems. And this is the reason why we see so much lawsuits right now going on over the training data, right? This data is what's going to be really important. Not only does it train the LLM and how to interpret that, but this also then becomes the context that's getting fed into these vector stores. Data sovereignty requirements means that global AI companies need distributed database architectures that can respect local regulations. Privacy preservation techniques like federated learning and differential privacy are creating new opportunities for companies with strong data practices. Now, the interesting thing about this is, like, we saw this big announcement from Microsoft, and they're like, hey, look, it can do all this, but it's not ready for real time. Why is it not ready for real time? Because they're using data that cannot be readily available to the public, right? And this race is going to be about who can figure out how to safely use these data, right? The billion-dollar question isn't which AI model is going to win. It's which database technology will become the standard infrastructure for AI applications. Traditional database companies like MongoDB, PostgreSQL, they're racing to try to add vector capabilities to compete with pure play vector databases. And the reason for this is simple, right? If I have a Postgres database that has all of my database in it, it's very easy for me to build an agent that'll pull against this data, just put it into a vector store and stick it back into the same database, right? I don't have to provide my application with a whole nother access to a different data store. But cloud providers are building integrated AI database services because they know where the customer lock-in really happens. Once you're locked into that vector data store, you're really not going to want to move it. Microsoft's success with AI comes largely from their ability to integrate AI capabilities directly into their existing database and productivity ecosystems. So, in my experience, the infrastructure layer always captures more long-term value than the application layer. And we're seeing the same truth with AI and with these AI systems. Now, what do you guys all think? Best compliment you can give me is to leave a comment down below, and make sure you like and subscribe. Here at Starter Pack, our specialty is connecting systems to help your company work to maximum efficiency. So make sure that you check out some of our services, and also if you're interested in becoming a registered apprentice in the state of Utah or in Idaho, we are looking for folks who want to join our registered apprentice program where you get paid to learn to become a software developer. And here's some great information about some of our services.
Hi, my name is Spencer Thomason, and I'm a fractional CTO. With over a decade of executive leadership and a solid 25 years in software development, I've mastered the art of transforming technology teams and products. So what is a fractional CTO? This is where you can contract someone like myself to come into your organization and get the benefits of a seasoned CTO without having to employ me full time. In today's fast-paced world, efficiency, security, and product scaling aren't just goals, they're necessities. My passion is building impactful products and enhancing organizational efficiencies through technology. From startups to small businesses, my approach leverages lean methodologies to not just meet but exceed your strategic goals. Whether it's through executive mentoring, cloud system architecture, or launching a minimum viable product swiftly, my aim is to make a significant impact right from the start. Recognized in the Arizona startup ecosystem, my journey has been about creating value and fostering innovation. I have led technology for companies like GoDaddy, SRP, and Wells Fargo and turned challenges into milestones. I've taken this learning and launched 7 of my own brands, and now I want to help you. So if you're looking for a fractional CTO who brings a wealth of experience, strategic vision, and a proven track record, let's connect. Together we can build technology that not only drives your business forward, but also makes a difference. Technology leadership redefined to fit your needs. So reach out today.